So we continue with practical chemistry part 2, and that we in the first part we discussed the uh, identify the gases which are neutral gases and acidic gases. Now we are going to identify the basic gases. So the next one is basic gases. So the first basic gas which I'm going to identify will be ammonia. In fact, okay, I misunderstood. I thought there is a complete list of the thing, but there's only one basic gas. Of course, there's only one basic gas, and that is ammonia. I could have taken it in the previous video itself, but anyways. So the basic gas we have over here is ammonia. Ammonia is the only basic gas. So color-wise, it will be colorless. Odor, of course, pungent. And finally, litmus will be moist. Red litmus turns blue. So that will be the way you are identifying ammonia by color, odor, and the litmus. Test wise, the first test will definitely be the same. We have learned it even in the chapter ammonia that while preparation we are just going to get a glass rod dipped in hydrochloric acid and we bring it near it, and when you find the dense white fumes of NH4Cl. So that will be our first test of ammonia, that is gives dense white fumes when a glass rod dipped in concentrated HCl acid is brought near ammonia gas. NH3 plus HCl concentrated will give you NH4Cl, which is dense white fumes. So that is about the first part. Second part is on passage through copper sulfate solution CuSO4, it gives a pale blue precipitate, that is ammonia dissolves in water gives NH4OH, and CuSO4 plus NH4OH gives you NH4 twice SO4 plus CuOH twice, which will be a pale blue precipitate. Now this is exactly what we did in the analytical chemistry as well as during the part of ammonia. That ammonia, when it reacts with copper sulfate, it is going to turn into a pale blue kind of a precipitate of copper hydroxide, and this is going to be soluble in excess of ammonium hydroxide. So on passage of excess ammonia or excess ammonium hydroxide solution, the pale blue precipitate dissolves to give you a deep blue or a inky blue solution of complex salt tetraamine copper sulfate. So CuOH twice plus NH4 twice SO4 plus NH4OH will give you NH3 4 times and SO4 plus 4H2O. So that is nothing but tetraamine copper sulfate, which will be giving you a inky blue or a deep blue color of precipitate. So this is what is the another test for ammonia. So first test of course was the ammonium chloride giving you a dense white fumes with HCl, and another one over here with copper sulfate is going to give you first a pale blue precipitate, and then on excess of NH4OH being taken, it gives you a inky blue kind of a solution because it is soluble in excess. The third, which is important again, is turns Nessler's reagent from colorless to pale brown or gives a reddish brown PPT, that is iodine on Millen base, okay, that required, on passage of ammonia in excess of Nessler reagent in the alkaline solution of potassium mercuric iodide. So that is K2HgA4I4 plus NH3 plus KOH will give you H2NHGOHG, and that is brown precipitate, plus Ki plus 2H2O. So this is Nessler's reagent turning. So of course the reaction is not important. What is important is what is the original color of Nessler's reagent. The Nessler's reagent is originally colorless and on passage through ammonia becomes pale brown. Okay, the pale brown color of the Nessler's reagent on passing through ammonia is a test for ammonia. So this is how you identify the gases. So you have identified totally 10 gases over here, 3 neutral gases, and then there are 6 which are the acidic gases and one which is a basic gas. Water vapor, hydrogen and oxygen, the neutral gases. The carbon dioxide, sulfur dioxide, chlorine, hydrogen chloride, hydrogen sulfide and nitrogen dioxide are the acidic gases, and ammonia being the only basic gas. Now we are going to see some action of heat on certain kind of substances. Of course, these things you had learned in the 9th standard. So it is just a recap of what we did in the 9th standard. So whenever any particular salts of carbonates or nitrates वगैरह heat करेंगे तो क्या होता है उसका, what is the decomposition reaction which is going to take place over here is what we are going to study in this part of the chapter, that is action of heat on substances. The first what you are going to take is copper carbonate. Now in this case, each and every color change what you see or any change in the color of the gas what you see are the most important observations over here. So copper carbonate, originally when you see, the copper carbonate is light green in color. Copper carbonate is light green in color. So when you heat copper carbonate, it is going to give you copper oxide plus carbon dioxide. So CO3 gives you CuO plus CO2. The CuO is black in color, the black metallic oxide. When they ask you black metallic oxide, one of the option for black metallic oxide is copper oxide. So copper oxide is CuO, which is black in color. So that is what you are going to get, plus CO2 as the carbon dioxide will be the thing. So you see, observation is original color light green turns black on strong heating. Gas evolved is carbon dioxide, which is colorless, odorless, slightly acidic to litmus, and test will be lime water turns milky and no effect on acidified KMnO4 or K2Cr2O7 solution. Residue will be copper oxide, which will be black in color, and reductions will be the light green powder is copper carbonate. So in case it so happens, you need to identify that which is this particular compound. So मुझे एक particular light green color का compound दे दिया, I need to identify कि वो क्या है. So what I'll do, I heat it. If I heat it, and what I get will be something like a black colored ka metallic thing, and I get some gas which is going to be evolved, which is going to turn the lime water milky and no effect on the KMnO4 paper. And then I know that carbon dioxide was released, so I now know that because carbon dioxide was released, it was a carbonate. And then I also know that because it is turning from green to black, so it is a copper. So hence I deduce from this particular or conclude from this thing that the given salt is copper carbonate. So this is also the way the question could be asked. It is not only the way that what is the heating effect of copper carbonate, it can also be, if this is the observation, what will be the compound which was taken. The next is zinc carbonate. Again, zinc, you can see zinc carbonate on heating. Now zinc carbonate is white in color, but as soon as you heat it, it is going to give you ZnO plus CO2. So all carbonates on heating give you zinc, the metallic oxides plus carbon dioxide. So that's why here also the zinc carbonate, which is white in color, will turn into zinc oxide and carbon dioxide. But here the main thing is that the zinc oxide has got a unique feature that when it is going to be hot, at that time it will be yellow in color, and when it is cold it becomes white. So zinc oxide, when hot it is yellow, and when it is cold it will be white. So this is a feature of zinc oxide. So observation, original color white turns yellow on heating. Gas evolved is carbon dioxide. So colorless, odorless, slightly acidic to litmus. Test lime water turns milky, has no effect on acidified KMnO4 solution. Residue is zinc oxide, which is a yellow when hot and white when cold, and reduction is that the white powder is zinc carbonate. Okay, got this thing? The next is zinc nitrate. So the next what we having is zinc nitrate. So 2ZnO3. So zinc nitrate again, because of the presence of zinc, it is white in color. So zinc nitrate is red in color. Now any nitrate when you heat, any nitrate when heated, it gives you metallic oxide plus nitrogen dioxide plus oxygen. So that's the most important part. What does the nitrate give you? Any nitrate will give you nitrogen metallic oxide plus nitrogen dioxide plus oxygen. The exception over here is the exception of potassium and sodium. They are going to just become they are not going to give me potassium oxide or sodium oxide. They are going to give me potassium nitrate nitrite. Okay, KNO3 will turn to KNO2. So that is some unique feature about the stability of the nitrate of potassium and sodium. So ZnNO3, which is white in color, is going to give you ZnO2, ZnO, So ZnNO3 twice will give you ZnO plus NO2 plus O2. Now the ZnO which is there, again we learned earlier that when it is hot it is yellow and cold it is white. So observation, original color white turns yellow on strong heating. Gas will be water vapor initial, in the cases will be water vapor, and then it will be NO2 plus O2. So nitrogen dioxide reddish brown, acidic to litmus turns moist Ki paper brown, and oxygen turns neutral and rekindles a glowing splinter. So these are the two tests which are going to be conducted on the gases which are going to be given out. So the gases will be reddish brown in color and the other gas will be rekindling the glowing splinter. The residue will be zinc oxide. The zinc oxide will be white when it is cold, but hot it will be yellow. So yellow when hot and white when cold. So the deduction is that the white powder is zinc nitrate. So you can see zinc carbonate also white, on zinc nitrate also nitrate. Now how do I identify that which was carbonate, which was nitrate? You are going to heat it. So when you heat it and if you are getting the reddish brown fumes, you know it is a nitrate. And if you don't get the reddish brown fumes and you are just getting the yellow colored hot part, then it is going to be a carbonate. The next we see is copper nitrate. So copper nitrate. Now copper nitrate CuNO3 twice, when it is heated, is going to give me copper oxide plus NO2 plus O2. So again I told you the nitrate when heated is going to give me metallic oxide plus NO2 plus O2. So here the same thing, there is no change in that. But the difference over here will be zinc nitrate was white in color and gave you a yellowish color residue. Here the copper nitrate is blue in color and the residue what you are going to get will be copper oxide, which will be black in color. I told you earlier also copper oxide is a black colored metallic part. So black colored metal will be copper oxide. So the difference between zinc nitrate and the copper nitrate will be the color when unheated. So when heated, zinc nitrate will give you a yellow colored the yellow colored metal, whereas this one will give you a copper will give you a black colored metal. So that metallic oxide. So that is the difference between the two. So originally it is blue and turns black on heating. Gas evolved is water vapor initial, but afterwards it will be NO2 plus O2, and nitrogen oxide reddish brown acidic to litmus and turns moist Ki paper brown, and oxygen turns colorless neutral and rekindles the glowing splinter. Residue is a black copper oxide form. So the residue which will be formed will be black copper oxide. So the deduction is that the blue powder is hydrated copper sulfate. Okay, so because it was blue in color, so we know it is hydrated. Otherwise, if it would have been white in color, it could be copper sulfate, which is anhydrous. But here it was given that it was originally a blue colored was there, so it was hydrated copper nitrate. Okay, sorry, it was sulfate. ठीक है, तो भी दोनों में आता ही है उसमें. So anyway, so you just remember one thing, that copper nitrate is is blue in color and it is hydrated copper nitrate, which is blue in color. The next is lead nitrate. So the next one is lead nitrate. So we are seeing three nitrates over here. Well, zinc dekha, zinc nitrate, then copper nitrate, and now lead nitrate. So again the reaction is the same. Lead nitrate will going to give me metallic oxide plus nitrogen dioxide plus oxygen. So the reaction doesn't change in any of these things. Any of these things, it's the same thing. So it is going to be metallic oxide plus nitrogen dioxide plus oxygen. What is the color change? The lead nitrate will be again white in color. Original color is white, but the lead oxide which is going to be formed will be buff yellow. So it will be a buff yellow. So that's why the change in color will be buff yellow. So the key observation is original color white crystalline solid turns buff yellow in heating. Precipitates give crackling sound, melts and fuses with the glass. So this is different. Now zinc oxide will not have the property of fusing with the glass. Zinc oxide is going to be yellow when it is hot and white when it is cold, whereas lead oxide is going to be yellowish and it is going to stick to the walls of the glass. So basically it will be fuses with the glass and melts and fuses with the glass on heating, which is a buff yellow color. Gas evolved is NO2, nitrogen dioxide, which is reddish brown in color, acidic to litmus, and moist KI paper brown. Oxygen colorless, neutral, and relits, that is rekindles the glowing splatter. So that is about the gases. Residue is litharge. The PbO is litharge, formed on strong heating, fuses with the glass. So this is the uniqueness of the lead nitrate, that lead nitrate is going to on heating forms litharge, which is going to fuse with the glass, which is not going to happen in zinc. In case of zinc oxide, such a thing doesn't happen. Zinc will give you a yellow colored thing only, but it will burn, it will not be fusing with the glass. Deduction, the white powder is lead nitrate. So that was about the different salts we are taken. So the salts we took was, first one was 2 carbonates, copper carbonate and zinc carbonate, and then we took 3 nitrates, copper nitrate, zinc nitrate, and lead nitrate. So that was about action of heat. Now we see the next thing, and that is the cations, that is the positively charged ions present in a particular compound. So the cation test is nothing but the same test what we studied in the analytical chemistry and also in the ammonia chapter. In the ammonia chapter, we studied what the parts which were there for ammonium hydroxide. We did not study about the NaOH, but ammonium hydroxide wala part to hum log ne wahan pe padha hai. As far as the analytical chemistry concerned, the complete thing is well understood by us in analytical chemistry. So we'll just quickly go through them one by one again, so that it just recaps the whole thing. So first thing is what you are going to take is going to take Fe2 plus iron. So it will be iron 2. Now the iron 2, whenever it is going to be reacting with the NaOH, then it is going to give me a dirty green precipitate. So you can see over here, they have the equations are given in the another table. The reaction, the color change are given in the first part, because whenever you are asked as an observation, you need not write the equation. That's why they have written separately over there. So you can see, observation wise, what I am going to write will be that NaOH, when it reacts with the Fe2 plus, that is iron 2 kind of cations, it will be there. Then it is going to give rise, or if I take FeSO4, then it is going to give rise to FeOH twice, which will be giving me a dirty green precipitate. A dirty green precipitate is going to be formed of FeOH twice, which will be insoluble in excess of NaOH. Even if I use excess of NaOH, it will be insoluble in it. The same thing also happens when I am taking ammonium hydroxide. Even if I take ammonium hydroxide, I am going to get the same result, that is I am going to get dirty green precipitate, and which will be insoluble in excess of NH4OH. So that was about Fe2 plus. The next what we have is Fe3 plus. So if I take Fe3 plus, that is if I am taking the salt of ferric chloride, that is FeCl3, then I am going to get FeOH thrice. Okay, I am going to get the precipitate of FeOH thrice, and FeOH thrice will be reddish brown in color. So I am going to get reddish brown precipitate of FeOH thrice when I am reacting the ferric chloride with NaOH, and the same results, and it will be insoluble even in excess of NaOH. The same results I get even when I am using NH4OH. So NH4OH, when it reacts with ferric chloride, it is still going to give me the same reddish brown color precipitate, and which will be insoluble in excess. The next we see is copper. So the reactions also I'll just read out. FeSO4, तो ferrous के लिए FeSO4 plus NaOH gives you Na2SO4 plus FeOH twice, or FeSO4 plus 2NH4OH gives you NH4 twice plus SO4 plus FeOH twice. Fe3 plus के लिए FeCl3 plus NaOH will give you NaCl plus FeOH thrice, and FeCl3 plus NH4OH will give you NH4Cl plus FeOH thrice. We now move to copper. Now copper is going to turn into a pale blue colored precipitate. Okay, a pale blue colored precipitate is going to be formed when it reacts with NaOH, and even in excess of it, it will remain insoluble. So CuOH twice, what is going to be formed with NaOH, is going to be giving me the precipitate of pale blue color, which is insoluble even in excess of NaOH. Now the same SO4 or whatever, CuCl2, whatever taken, if I am going to react it with NH4OH, then firstly I am going to get the same pale blue colored precipitate, but on adding excess of ammonium hydroxide, I am going to get a inky blue or a deep blue colored solution, which is because it's going to be soluble. So the the copper hydroxide which is going to be formed is going to be soluble in excess of NH4OH, giving you a inky blue or a deep blue colored precipitate. So pale blue precipitate of copper hydroxide, CuOH twice, which is insoluble in excess. Pale blue precipitate of copper hydroxide, CuOH twice, which is soluble, giving deep or inky blue solution. The next is calcium, Ca2+. Milky white precipitate of calcium hydroxide, CuOH twice, which is insoluble in excess. So here calcium is something which is going to be reacting only with NaOH. So when it reacting with NaOH, it is going to give me a white colored, the milky white precipitate, which is going to be insoluble in excess. Whereas in case of NH4OH, it does not give me any precipitate at all. So no precipitation takes place when calcium salt is going to react with NH4OH. The next salt we are taking is zinc. So zinc, when it reacts, so zinc sulfate or zinc chloride, whatever I take, zinc is going to give you zinc hydroxide, and then ZnOH twice will be giving you a gelatinous white precipitate. A gelatinous white precipitate is going to be formed when NaOH is going to react with the zinc salt, and that is soluble in excess of NaOH. So zinc hydroxide is soluble in excess of NaOH. Why is that so? Can you think about it? Yeah, it is basically because amphoteric substance. Okay, it is an amphoteric substance. That's why the zinc hydroxide is going to react with sodium hydroxide to give you a zincate. So that is the reason you are going to get a zincate, which is a soluble part. So gelatinous white precipitate of zinc hydroxide, ZnOH twice, which is soluble in excess. Same thing happens even in ammonia. Ammonia also gives rise to a gelatinous white precipitate, which is going to be ZnOH twice, and also when it is going to be added with excess of NH4OH, it is going to give rise to a soluble kind of a salt. So the soluble kind of substance is going to be formed on doing so. So you see ZnCSO4 plus NaOH will give Na2SO4 plus ZnOH twice. Then ZnOH twice plus NaOH will give you 2H2O plus Na2ZnO2. So that is the zincate which is formed. Similarly, ZnSO4 plus NH4OH will give you the NH4 twice SO4 plus ZnOH twice. ZnOH twice plus NH4 twice SO4 plus NH4OH will give you H2O plus ZnNH34 plus SO4. The last over here, no, second last over here is lead. Now, lead, when it is reacting with sodium hydroxide, NaOH, it is going to give rise to chalky white precipitate. So, zinc gave you a gelatinous white, whereas lead gave you a chalky white. Now, of course, when you are seeing it experimentally, there is hardly any difference to identify between gelatinous white and a chalky white. So, of course, exam में लिखने में क्या फर्क नहीं पड़ता gelatinous डालो या chalky white डाल दो, we know that thing, but identification में actually practically जब भी करने जाते हैं तो इतना easy नहीं होता to identify it. So that's the reason we are going to have two tests done. One is a test with NaOH, another will be with NH4OH. Why is that so? Because in case of NaOH, it is soluble in excess, but in case of NH4OH, lead is insoluble in excess, and that becomes a differentiating part between zinc and lead. Zinc hydroxide is soluble in excess of NH4OH, whereas lead hydroxide is not soluble in excess of NH4OH. So you get over here that Pb2 plus will be give you chalky white precipitate of lead hydroxide, which is soluble, and whereas chalky white, when with NH4OH, it is going to give me chalky white precipitate of lead hydroxide, which is insoluble in excess. So PbNO3 plus NaOH will give you NaOH twice plus PbOH twice, and NaNO3 twice plus, NaNO3 not twice, plus PbOH twice, and PbOH twice plus NaOH will give you H2O plus Na2 PbO2. Whereas in case of NH4OH, PbNO3 twice plus NH4OH will give you NH4NO3 plus PbOH twice. So that's about the, but now the last one is ammonia. So if I am taking an ammonium salt, so on heating with NaOH, a gas is evolved which turns moist red litmus blue, that is ammonia gas. So that's why ammonia gas is going to be released when reacted with NaOH. And on heating with NH4, no change is seen because, of course, ammonium salt is not going to react with ammonium hydroxide. So that's why there won't be any change taking place when ammonium salt is reacted with ammonium hydroxide. But with sodium hydroxide, yes, it is going to give you the gas which is nothing but ammonia. So you can see NH4OH, when it is going to be heated with the NH4Cl with NaOH will give you NaCl plus H2O plus NH3 as the reaction. So this was the different kind of cation test. The test for cations are given in this way by the use of NaOH and NH4OH. Apart from this, if you want to test the cation, the other option to test the cation is the flame. So a flame test applicable for identification of cation. So method wise, what you are going to take is thin platinum wire is thoroughly cleaned and heated in a non-luminous flame of burner. The color imparted of the flame will be golden yellow, and which will be persistent, which will be on passing through a blue glass. So if I take a blue glass and see that thing, it will be looking pale yellow, and in such a case the metallic radical which is present over here is sodium over here. So it is metallic radical will be sodium. Now if I take the so I see that if I want to identify, now you can see that in the above thing of the potassium, in ferrous and all, we never identified potassium, sodium and calcium and all. So there, if I want to identify the cation to be as potassium, sodium or calcium or copper, then I can use also the flame test. So in the flame test, what we are doing is we are going to just take this platinum wire, dip it over there and then heat it, and if it gives you a golden yellow color, then it is going to be sodium. In a blue glass, it will look like pale yellow. When the wire imparted no color, it is dipped in concentrated sulfuric acid, concentrated hydrochloric acid, and then it is and into the substance to be identified. So the wire is then introduced into the non-luminous flame and the burner, and the color imparted to the flame is seen through a naked eye. And so this is the complete method. The method is common for all of them. So method is first, platinum wire is thoroughly cleaned and heated, and then heated in a non-luminous flame of the burner. Uske baad, when the wire imparts no color in its change, so then dip it into HCl and then into the substance to be identified. Then the wire is then reintroduced into the non-luminous flame and from the burner, and the color imparted of flame is seen, and वही flame you are also seeing through a blue colored glass. You understand? What you did was platinum wire लिया, platinum wire को thoroughly clean किया, उसके बाद you heated it, and you heated it to see what is the change in color. So there you can see there is no change in color, and then what you are going to do is you are going to take that particular platinum wire and dip it inside the concentrated hydrochloric acid, and then dip it into the substance which is to be tested. So like sodium लिया या पोटेशियम लिया या कैल्शियम लिया, उसमें डिप किया, और डिप करने के बाद में you are again going to put into the flame. So when you put it in the flame, non-luminous flame is the blue colored burner, तो उसमें डाला, Abhi, see the color change and also see the color change through a blue colored glass. So you're going to take a blue colored glass and see. और मिस्टर इंडिया में ना रेड कलर के ग्लास से वो दिखता है, वैसे ये ब्लू कलर के उसमें देखना है हम लोग को. So color imparted will be golden yellow or pale green in blue color. It is sodium. If it is lilac color and non-persistent and it is violet in blue colored glass, will be potassium. If it is brick red color, it is brick red color with non-persistent and it is pale green in a blue glass, it will be calcium. And if it is green and which is pale green in blue glass, it is copper. So in this way, we can identify the colors as golden yellow for sodium, lilac for potassium, brick red for calcium and green for copper. So these are the identification of the cations which are present in a compound. We now move on to the anions, but in the next video.